Well, hello. It's been a little while. I'll explain exactly why. There's been a little delay since I did my last talk, but this one's going to be an interesting one. I'm excited about this one. 3D GIS and augmented reality are here. Are you ready to go? Some of this is actually coming out from the last talk I did, which was spending a week in Palm Springs with Esri. So let's charge forward and explore this exciting topic. Well, let's start this with a quiz. Where was I last week? You'll see in that picture there, can't point properly, that picture there, that's me with a rather large mountain behind me. You get a prize if you can tell me what that mountain is. You usually see that actually from the other side. So two-part question, what is that mountain? Where is it? And then which ski resort am I at in that picture? There it is. So, on to today's topic. I pulled a slide from the last presentation I did, the last talk I did, which was, again, one of the themes that came out of the Esri conference last week or 2 weeks ago. And this was around 2D and 3D. And I listed some things in the slide here. There was much conversation about 3D systems of record, 3D visualization analytics. Velocity was more real-time. We're not going to talk so much about real-time in this one. Game engine integration, which is relevant here. And then immersive and augmented reality. Augmented reality is one of the themes here. So we really are seeing an advance in the technology. And I wanted to talk in a little bit more depth about specifically 3D and augmented reality. So let's just talk through this. 3D GIS points and lines. Now, one of the areas of focus that I have within my job at Lacana is around the utility network, and there's a specialty at Esri called the utility network management specialty. But the utility network is quite a big advance for utilities. It actually allows utilities to move from, for example, substations being a point on a map to actually being able to collect data on each of the assets within a substation. Some of these are quite complex pipes and valves, etc., that are all interconnected. GIS historically really hasn't been used for that kind of work, and the utility network is primarily used for connectivity, for predicting outages, etc., etc. But we've now got it down to a very, very fine level. The utility network supports 3D. This is important. So this diagram here is a 3D points and line diagram. Now this could be the interior of a substation. And if you've ever seen pictures of this, they're very complicated, all collected together. We have pipes above valves above pipes. So to actually have that data within a GIS is relatively new, and very few utilities have actually got that. But the real value of the utility network is to collect that data, that three-dimensional data of assets, of complex assets. So again, we go down to the micro level of assets. So this is already in place. One of the areas of focus that I'm involved in is collecting that data and publishing that to the utility network, so we can run all sorts of analyses within the utility network. So again, front and center 3D. This is points and lines. Let's move to the next thing. So 3D GIS and digital reality. Now, there's a huge amount of work that's now gone into building both desktop applications, in Esri's case it's ArcGIS Pro, but also more importantly web applications. And if anyone knows that the ArcGIS JavaScript 4 supports 3D, so there's a lot of web GIS that's happening, 3D GIS that's happening. That's an example from Esri. That's not just in the Esri world, it's also outside of that. There's 𝐂𝐨𝐬𝐻, which is an open source technology which can present the world in 3D. So this is digital reality, and there's a lot of work being done in collecting data to build reality models of the world, not just with LiDAR. Everyone talks about LiDAR, but it's also imagery as well. And again, I'm working with an organization that's doing some really interesting work. Actually, it's Miles Sutherland's organization. If you've seen any of our collective webinars together, Miles, myself, Jim, and Chris, you'll have seen Miles. He's doing a lot of fascinating work using it, collecting imagery and then generating 3D from that imagery. So more to come on that. So let's just switch gears for a second. Let's talk about augmented reality. Now, here's a pretty wordy definition of augmented reality. Augmented reality is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information. I don't like that very much. I could have made it a lot shorter, but there we are. That's an official definition from Wikipedia. So let's just consider augmented reality briefly. So let's just quickly talk about augmented digital reality. That's slightly different to the definition I just gave there. And what I'm going to do here is run a very short video which gives you a sense of what we're talking about here. There's actually a bigger story to this video which I'll actually talk through. So this was work that I did. If I can get this thing started. This is work that I did a few years ago with a group. So this shows you a two-dimensional map, and what we're showing here is collisions and intersections. So we've got a heat map there, we've got clustering, etc., etc. And there are different widgets in this application that allow you to filter the data differently. But what safety engineers are interested in is to isolate those most problematic intersections. That's based on serious injuries and deaths. So they assess where they should be looking at. The next thing they do, and I'll just pause the video there, is they actually drive out to an intersection. And that's what we're zooming into in the video here. We're actually zooming into one of the problematic intersections. When I was talking to the safety engineers, I asked them, if you could do this digitally, would that help you? And they said they'd never seen anything like that before. So we put this demo together. So it allows an engineer to sit in his office, to click on that intersection, and to then actually zoom in 3 dimensions to that intersection. And this is LiDAR data. So there's that intersection. We're just populating the LiDAR now. And what we'll start to do is interact with that intersection. So again, I'll pause the video in just 1 second. So we've got 3D collected by LiDAR of that intersection. I'm just going to pause it there. The other thing that we did was, now clearly those crashes weren't there when the LiDAR was taken. Somebody drove down that road. But I wanted to add the augmented piece to this, augmented digital reality. What we did in this example was we actually took LiDAR of actual crashes that happened at the intersection, and you'll see one there with a motorbike, and we just added that to the application. You'll also see, I don't know if you can see just to the left there, there's a green dot just there. That's actually GIS data. So we added point data where all the crashes happened at that intersection. So not only did we create a 3-dimensional version of that environment, that they could actually then get a sense of what it looked like. And again, this being LiDAR, they could actually do measurements, and I'm not going to show the full video. They could sense if there was overhanging vegetation, etc. But we could add additional data to that information, so the crashes, the GIS data. So we augmented digital reality. If they'd gone out there and had the trouble to go out with a tape measure and measure things, look around, that's not as effective as doing it digitally, where we can actually not only present a digital representation of that intersection, but also add additional data to help them diagnose the problem and therefore fix a problem, in this case maybe to build a roundabout. So it's a very effective way of doing things. So I wanted just to show that to you, because there's a workflow there from 2D to 3D and how effective that is in telling an interesting story, but also augmenting that with additional data sets which help safety engineers more effectively diagnose a problem and fix it. And we know how important that is in terms of, you know, cutting down collisions and injuries on the road. So that was an interesting one. So let's move on. I wanted to talk about artificial AR data and give you an example about the kind of data that's now being collected where our AI is going to be super useful. So this is one use case. Now there's a lot of work being done on what's under the ground. So there are now these sensors, it's radar that penetrates the ground and actually picks up on objects that are beneath the ground. So this can be driven. In this image, they're actually walking along. But we're now beginning to map out what's underneath the ground. So that's the data. So how do we visualize that data? Now again, we're in the early stage of this, but one of the examples that I'm going to show you here is I'm putting it the wrong way. This is digital reality. So this is a 3D version of something, a manhole that sits underneath the ground. So this data has been collected, it's been processed, and then it's been visualized. And in this case, this is sort of in a traditional web interface that it's been collected. But that's not much use to a guy that's actually in the field. Let's imagine a guy that's digging and wants to know if there's a pipe under the ground. So where we're moving to, and I think this is fascinating, I'll do another one on this, are glasses. So we keep hearing about virtual reality and augmented reality with, you know, the Oculus type where you're embedded in that world. I think that's a long way off. I'm still struggling to see how that's going to be that's used to people who are working in the field. But glasses like Google Glass enable people to put glasses on, have those glasses connected to the iPhone in their pocket, for example, and to feed data from a GIS, for example, to those glasses. So somebody can be in the field, put the glasses on, have GIS fed from ArcGIS or somewhere else, and actually be able to see those pipes that run underneath the ground. So it will be in the field with augmented reality, showing us things that are underground, things that we can't see with our own eyes. I mean, there's obviously much more to augmented reality than that. We can actually find out other information about the reality that our eyes can see, but we can't see with our brains. So this helps us understand more things. I'm really excited about that. And again, I'll do another talk on that one in the near future. But these things are now being built. These things are now quite possible. So I wanted to have parting thoughts. So I will leave you with this. If you are still only focused on GIS business as usual, you're falling behind. And I will say that my reflections on what I saw at the Esri conference and what I'm seeing in the widening world of geospatial is the traditional way that we've worked with two-dimensional maps is becoming less and less relevant. And what's happening is we're now getting new data that we can analyze and visualize in different ways. 3D and augmented reality being two really good examples of that we now need to start thinking about, and how we can best implement that, because the technology is there, the data is there. We now have to then find the use cases to apply that technology to help folks solve problems that they couldn't do before. So there's your talk, and I'll be back very soon with another one. Thanks very much for watching. Thanks for joining us on the Geospatial-Next channel. We're focused here on understanding the future of geospatial. That's both how we get to mainstream adoption of the technology and data, and how we start using blockchain and crypto to move things forward. Please feel free to subscribe to the channel, and we'll look forward to seeing you next time.